Hello and welcome back. We are looking at higher maths functions and graph sketching trigonometric functions. We're going to look at an example with a coefficient of x larger than 1 this time. So in the previous two examples it was 5 cosine x plus pi by 3 and 2 sine of x minus 30. So this time sketch y equals 3 sine bracket 3x minus 60 plus 2, 0 less than equal to x less than equal to 360. So what we need to do here, first step, is to take out a common factor of 3 inside this bracket. Okay, if we don't do that first, we are not getting the correct answer. So we must do that. That is the first thing we must do in a question like this. Once we've done that, we just approach it in the same way as question 1 and 2. So it's a trickier question than 1 and 2. The reason why it's trickier is we've got this extra 1 step in. So we've got 3 at the front, which stretches in the y direction by a factor of 3. We have the plus 2 on the end here, which will move the whole curve up by 2. Here the 3 will compress the sine curve by a factor of 3. Just like sine 3x from National 5, you'd have 3 complete waves in 360. So what's really happening there is the whole sine curve is being compressed by a factor of 3. And the x minus 20 here moves the whole curve along by 20 degrees. So let's look at our mapping here. So the x coordinate was going to be compressed by a factor of 3 and then moved along by 20 degrees. So whatever the original x coordinate was, we're going to find a third of that, or we're going to divide that by 3 and then add on 20. The y coordinates, we are going to triple those because we're looking at 3 sine, not just sine, and then plus 2 because we have this plus 2 on the end. So as it's a sine graph, here are the 5 key points. And the transformations will be 20,2, 50,5, and so on. Okay, so we have the key points. As always, we really want to know where the y-intercept is. So substitute into either here or here. Remember, this is the same thing written a different way, so either one's fine. So 3 sine of negative 60 plus 2. So that'll be negative 0.598 or negative 0.6. We could write that as an exact value, but because I'm sketching the graph, I'm just going to leave it as negative 0.6. So if you're thinking I would rather write negative 3 root 3 over 2 plus 2, that would be totally okay. So let's plot these points and also the y-intercept. So there are the first points. So I'll take us to here. Now, as we know, a sine curve has exactly the same period for one complete wave. So I'm just going to put in my second wave and my third wave. Okay, and because we have this 3 here, it's been compressed by a factor of 3. The period, rather than being 360 degrees, will be 120 degrees, which comes from 360 divided by 3. So the maximum turning point here is 50,5. So there'll be another one occurring 120 degrees later, and then a further one occurring another 120 degrees after that. And in a similar way, the minimum turning point at 110, negative 1. Then we've got another turning point there, another minimum turning point there. And that is that. So if you're okay with 1 and 2, it does extend from that, but really there's just this compression to take into account. And if you're fine with mapping that, then after that you're just making the sketch again.